Hello, class. We will go over today uh, on solving other type of equations, section 1.6 of the textbook. So again, here I will solve some problems to show you some examples. However, you have to read the textbook uh, in order to understand better. So the objective are solving radical equations, solving equations with rational exponent, solving equations that are quadratic in form. So each one is already defined, so I'm going to go ahead just remind you that a radical equation means an equation that involves a radical, and then means a variable is in a radical, and equations with rational exponents are equations where the variable has a rational exponent, and then equations that are quadratic in form are equations, if you do a right substitution, you end up with a quadratic equation. That's why we call them quadratic in form. So let's see an example of each. So first we will solve a radical equation. So example, so solve a radical of 20 minus 8x equal to x. So in a radical equation, the first step is to isolate the radical, but here in our example is isolated already. So if we have, for example, a 4 time here, we have to divide the other side by 4 on the first side. So isolate the radical first. Once you isolate the radical, so you can square both sides. So we're going to square it. So radical of 20 minus 8x equal to x squared. So once you square it, means the radical gonna go away, so it's gonna be just 20 minus 8x equal to x squared. Now as we see, it will be transformed in a quadratic equation here. So means we put one side equals 0 and then we solve it. So we can say we can minus 20. As the power 2 is at the other side, we're going to keep that side. So minus 20 plus 8x. So minus 20 plus 8x. So it's going to be 0 equal to x squared plus 8x minus 20. So you know, the first thing to do in solving a quadratic equation is to check if you can factor it. So in that case, because we have the coefficient of x squared is 1, we can just look for factors of negative 20 that add up to 8, the middle number. So negative 20, we can say equal to 10 times negative 2 and 10 plus 10 plus negative 2 equal to 8. So the two factors, 10 and negative 2, are good. So we can say 0 equal to x plus 10, x minus 2. So we can set x plus 10 equals 0 or x minus 2 equals 0. So we end up with x equal negative 10 or x equal 2. Every time you solve a radical equation, you have to check the values you found. These are just called possible solutions. We have to check in the original equation if it makes it true. If it makes it true. So we have to check negative 10. So let me just erase one side. So now here is this. So check -10. So in the original equation, so it's going to be radical of 20 minus 8 times -10 equal to -10. So radical of 20 plus 80 equal -10, or radical 100 equal to -10. Radical 100 is 10. 10 equal to -10. This is a false affirmation, is a false equality, so false. So means -10 is called an extraneous solution. We have to reject it. -10 is extraneous, rejected. So it's not a solution. We have to reject it. Now we check 2 the same way. So check 2. So check 2. So radical of 20 minus 8 times 2 equal to 2. Radical of 20 minus 16 equal to 2. Radical of 4 equal to 2. 2 equal to 2. So this is true, so means 2 is a solution. Finally, because we rejected -10, the only solution is 2. So solution. So the solution is 2. This is the final solution here. 2. So as you see, what you're supposed to do, isolate the radical, square both sides, and then solve the resulting equation, and then check always your possible solutions. So now we will see an example of rational exponent. For rational exponent, we will see 2 examples. One where the numerator is even of the rational exponent, and the other where the numerator is odd, because it's different ways to solve for those. Let me just pull an example of example 2. So in this example, we will solve x to the 3/2, exponent 3/2 equal to 27. So in this case also, like in the radical equation, you have to isolate the expression with rational exponent. Is isolated here. So once it's isolated, you check out the numerator. The numerator, so we have 3/2 equal m over n. So if m is odd, there is one solution. So because m is odd, 3 is odd, there is one solution. The solution will be solved as here. We have to take a reciprocal of the power, so we say x equal 27 to the 2/3, the reciprocal of 3/2. What is 27 to the 2/3? It's just cube root of 27 squared. So x equal 3. Cube root of 27 is 3, so 3 squared. X equal 9. So this is our solution here. You can verify it from the original equation. Okay, so now we're going to see another example where the numerator will be even. So in that case, there must be 2 solutions. So let me just erase this. So example 3. example 3, we will have a rational exponent equation with an even numerator for the rational exponent x to the 2 over 5 equal to 9. So 2 over 5 equal to m over n, and m equal to is even. So we will have two solutions. So we will enter this here, a plus or minus. By the way, I just remind you that you still have to isolate the expression with the rational exponent first on one side. But here is isolated. So we will say x equal, we enter this a plus or minus for the two solutions, 9, and then we take the reciprocal of 2 over 5, 9 power 5 over 2. So once we do that, now we can just simplify it. So this is just equal to radical of 9 plus or minus power 5. So x equal plus or minus 3 to the 5th power. So we can calculate 3 to the 5th power, 9 times 9, 3, 243. So these are the two solutions for this equation, okay? Remember, when the numerator is even, introduce a plus or minus. When it's odd, there is one solution. So lastly, we're going to see an example with equations that are quadratic in form. So example 4. We will solve an equation that is quadratic in form. So example, x to the 4th power minus 13 x squared plus 36 equal to 0. So in such equation, it's called the quadratic in form because when we do a right substitution, we end up with a quadratic equation. So let's consider this as x squared. Usually is based on the power in the middle. For example, we have x squared here. We try to have it here at the beginning. So we can say is x squared minus 13 x squared plus 36 equals 0. So what we do here, we can let u equal x squared. So the equation will become u squared minus 13u plus 36 equals 0. So as we have a quadratic equation now in u, we see if we can factor it. We check factors of 36 that add up to negative 13. So we would say negative 4 times negative 9, and negative 4 plus negative 9 equals negative 13. So this is going to be just u minus 4, u minus 9 equal to 0. So we can say u equal 4 or u equal 9. We back substitute now u for x squared. So x squared equal 4 or x squared equal 9. So means x equal plus or minus radical of 4 or x equal plus or minus radical of 9. So the first one gives us x equal plus or minus 2, and the second x equal plus or minus 3. So these are the solutions. Remember that you're looking for x values, not u values really. So u is just transitional. So you make sure you go back to x and then have the solutions as values of x. So So this was for today, for this lesson, and thank you. I see you next time.
Good. Very good.